Hey everybody. Today we're talking about conditional probability and the multiplication rule. The conditional probability of an event B given A, written like this, is the probability that event B occurs given that A has occurred. An example: 2 cards are drawn from a standard deck without replacement. In other words, you don't put the first one back before you draw the second one. We're going to let A be the event the first card is a king, and B be the event that the second card is a king, and we're going to compute the probability of B given A. So A means that we've taken out one of the kings from the deck. Instead of having 52 total cards, we only have 51 now, and instead of 4 kings, we only have 3 now. So the probability of B given A is 3 divided by 51, about 0.059. Another example: a researcher contacts 1,250 adults at random and asks whether they prefer dogs to cats. And so the results are here, and they're broken down by age groups. Find the probability that a respondent over the age of 55 prefers dogs. This is a good place to pause the video. Try it yourself before seeing my solution. So if B is the event that they prefer dogs and A is the event that they are over 55, we need the probability of B given A. So really we're just looking at the 55 plus column here. That's sort of our universe here, our sample space. And there are 143 people in that column that prefer dogs. Out of 325 total, it's about 44%. Conditional probability is particularly useful when you need to calculate the probability that 2 events both occur. The multiplication rule says that the probability that 2 events both occur is the probability of the first one times the probability of the second one given the first one. For instance, let's take another 2 cards from a standard deck without replacement and find the probability that both are kings. So for the first draw, there are 4 kings out of 52, so 4 out of 52. And then for the second one, we assume that the first one was a king. So we have 3 kings left out of 51 cards total. We multiply 4 over 52 by 3 over 51. We get about 0.0045. One last example. A server at a restaurant has observed that the chance that a customer orders alcohol, call that event A, is 40%. The chance that they order an appetizer, event B, is 30%, while the chance that they order both is 20%. I want to find each of the conditional probabilities, A given B and B given A. Another good place to pause the video before I advance. In each case, we're going to use the multiplication rule there. The difference here is that we have to do a little bit of algebra, because instead of trying to find the probability of A and B when we know the probability of A given B, it's kind of the other way around. We know the probability of A and B here. So I am going to plug into that multiplication rule, plug in 0.2 for the probability of A and B, and 0.3 for the probability of B, do a little bit of algebra. The probability of A given B is 2/3. So that's the probability that they order alcohol when you know that they're ordering an appetizer. The other way around works exactly the same way, but we get a different result. We're going to use the probability of A and B is the probability of A times the probability of B given A. So in the first part of this example, the right-hand side of that top line said probability of B times the probability of A given B. So again, probability of A and B is still 20%. The probability of A is 40%. We do a little bit of algebra. We get the probability of B given A is 1/2. The probability that they order an appetizer when we know that they've ordered alcohol is 50-50. Notice that these 2 conditional probabilities are not the same. The probability of A given B is not the same as the probability of B given A. And that's pretty much always the case.